Hello everybody, I'm Marcos, CPO from Atlas, and today I'm going to show you how to use our newly launched Atlas SDK to be able to execute Web2 code into Web3 environments, such as EVM chains. So in this tutorial I'm going to be playing around with some C code and deploying it on the Binance testnet, but you can use any other EVM of your choice. And I'll show you how to register and how it is a really straightforward process. So the first part is that you go to the Chains Atlas website, chainsatlas.com, as you can see here, and you can just click on this sign up button, and then you will be redirected to this sign up page, which is very simple. You just need to put your information such as name, email, a password, and we just ask you like two questions about your company size and your company sector, and this is just for us to get to know you a bit better and ensure us that we are prioritizing the right features for our users. Okay, and then once you create an account, you can come here at the login page. I already have an account, so let me just log into mine. And once you create an account, your API key will be generated automatically for you, right? As you can see here, you will be able to copy this to clipboard by clicking on this button. And after this, you will be able to use the Atlas SDK NPM package that we have. So you can go to the docs part here, and this will show you our GitHub repository for the Atlas SDK. It has a pretty concise guide on how to use the SDK, also with examples implemented with the main JavaScript libraries that we have nowadays. So this means Web3.js, Ethers.js, or VM. Okay, and you have some examples in all of these, in three of these libraries. And I'm going to guide you through here quickly through this documentation, but looking at the code itself later, you can go ahead and check our repository, check the information in detail, also check our white paper that will be listed here. Okay, but let's cut to the chase. So I have a VS Code here open, and it's a very easy and standard code that I have here, which is quite boilerplate for Web3 developers. I'm just creating instantiated a provider and my wallet, given my private key, and then I'm deploying a contract, which is a virtualization unit contract. And for those of you that are not familiar with it, the virtualization unit is one of the Chains Atlas cutting edge technologies. It's the core of our technology, really. And what it really is a smart contract that contains in itself a virtual machine that it's able to execute Web2 code into Web3 environments, right? Right now we already support all of the EVM chains that you can test, and mainnet also. When I say test, is that you can go ahead and test it. And we are also working on other architectures, integrating with other architectures. So right now we are working to integrate with Stellar, and we also have integrations going on for ELF chain, and more is to come. So please, if you also have any feedback or any other chains that you would be interested for us to support, please go to our Discord channel, and you can see the link on the description of this video, and we'll be happy to hear you out. Okay, so moving along, you basically just install the SDK. As you can see here, it's a simple command using EPM, yard, or pnpm, whatever is the package manager that you like the best. And once you install it, you will need to import four things from it: the client, the compose input utility function, and then the virtualization unit ABI and the virtualization unit bytecode, so you can deploy the virtualization unit contract and use its methods. Okay, so for this example I'm using ethers, which has good support for TypeScript, but you can use also web3.js or VM too. Okay, so right now this code, I'm instantiating my RPC provider, and then I'm creating my wallet. These are for the Binance testnet, just being clear. Then this code is basically deploying the contract. Then later I create the SDK client with my API key. This is a function, by the way, run code, that I will be calling later on at the bottom of this file, and it will take the API key that we just got from the Chains Atlas dashboard, and these other three arguments, the code, the number of arguments and args, I'm going to show to you where you will insert it. Okay, so first we instantiate the client by passing the API key. This is the Chains Atlas client, and what it does is that it enables you to communicate with the Chains Atlas API. And what the Chains Atlas API does, so a lot of people, when we talk about the virtualization unit and Chains Atlas being able to execute Web2 code into Web3 environments, they think that we are executing the code off-chain and then just logging the result into the blockchain, and that's not what's happening at all. Okay, so what we're doing is that all of the code is executed natively on chain. The only role of the Chains Atlas API is basically just to compile your C code to a bytecode that is compatible with the virtualization unit architecture. Okay, so that's all that it does, and you can see the rest of the code to prove it. So since it's open source, so you can check out the SDK too. And so the SDK client has this function called compile, and basically what you give to it is your code content, the language that you're using right now. So for this example, we're using C, and the number of arguments that your code has, right? So for example, let's suppose that I have a silly sum function in C code, then it would take 2 arguments, and then I would just paste the number 2 here. All right. Then once we have that, I just use this utility function called compose input, which takes this client bytecode that is returned by the compile method of the client by our API, and given a set of arguments. So let's suppose again that you have the silly sum example, right? So I give 2 numbers, I give 5 and 5 because I want to sum it to 10, for example. So this is where I would pass these arguments as an array in the order that they are requested, and I'll give the client bytecode returned by the Chains Atlas client API. And what this utility function does, it's basically interpolates the client bytecode to add the arguments at the right places in the bytecode so that the virtualization unit is able to execute it correctly. Okay, then we have this bytecode input. We assign this result to the bytecode input variable, and then we pass this bytecode input, which is basically the compiled bytecode given the right arguments that you want it to be executed with, to the run bytecode method of the virtualization unit contract. Okay, and it will run this contract. You will get the receipt here, and after you have the receipt in your hands, you can use event filters of the contract to get the topic filter and get the runtime return for your execution. So again, using the simple example of a sum code that takes 5 and 5 and sums it to 10. And then with this code here, you will be able to take the logs and the return runtime return and get the return value, which in this case it's 10. Okay, and then at the end, I'm just pasting here the output and parse it to an integer, since it will be on hexadecimal format, and also the transaction hash so we can verify it on chain. Okay, so here I'm just taking the source code of some of the C files that I have here, for example, and then I'm passing here the source code to the function that I just described to you, and I'm also passing the number of arguments and the arguments themselves, right, alongside with my API key, which I just pasted here, that we got from our Chains Atlas dashboard here. Okay, actually this is a different one. Let me paste it. Alright, so this is my new API key, and then we'll log in it so we can check it out. So before I execute this, I'm just going to show you the C code that we are going to execute. So for now, we're going to start with the simple sum C file that I showed here, and this is the file. So it has a main function, and it's very important that you have your main function named main instead of entry or other stuff for now, because this is the function that the virtualization unit will look for in its current iteration. All right, later on we'll add more features to make it dynamic, so that you can specify which function you want it to start with, but for now this will work by using main. And it's a simple function, so you take two integers and sum them together, and you might notice there are two lines here that have something a little bit different, and this is these two lines here, line 7 and line 8, right? Because it has this weird function called Chains Atlas EVMS load, and what this does basically is that it tells the virtualization unit to use some of the EVM intrinsic operations to load arguments from memory. So remember when we specify the number of arguments that your code has and the values to it to compose input, for example, what this function does, it's basically telling the virtualization unit, okay, you have these two variables x and y, and you're going to load them from memory, and in the following order. The first one is going to be loaded into x, and the second one will be loaded into y. Okay, so this is important that you number this as load calls accordingly to the order of the arguments that you pass when composing the bytecode input. Okay, and once it does that, it will sum the result. All right, so just explaining this to you, because this is relevant for the purpose of this tutorial. Now I'm just going to run the npm start here so we can execute this code. So again, it's a sum. I'm summing 42 with the number 8. It should output 50 in this case and give us the transaction hash. Okay, so I just need to wait a little bit for it to send the transaction and confirms it to get the receipt. Okay, so as you can see, the output correctly is set to 50, and this is the transaction hash. So let me just copy it, right? And here is the Binance Testnet Explorer, so we can just type the transaction hash here to verify it, and you see it's a success. It was 27 seconds ago, and here is the confirmation of the transaction. Okay, so this indeed went through. Now let's try other examples, right? Because some is very simple, it's nothing interesting happening there, but we can build more interesting stuff, such as, for example, we have a factorial here which kind of does the same thing. You give it an integer, will calculate the factorial for you, but we can also go into something a little bit more complex, like the 2048K. So this is really interesting for Web3 gaming developers, right? Because sometimes I see that some Web3 game developers, they have some cool interfaces, they have some cool game logic, but they are often executing it off chain and just logging the results and the scores into the chain, right? And while that's a reasonable workaround for now, I think it would be much safer and much better for your users if they could know for sure that the game logic is being executed on chain, specifically if your game involves some pseudo random logic, you know, and stuff like that, so that they know for sure that the gaming logic is indeed working as it's supposed to be, and there's not some tampering with it, right? I think this is especially important in those cases. So what you have here is that we have a lot of functions to make the 2048 board game work. A compute score main, you can take a look at it. We'll post all of these code examples in our website as content too, so you can check it out and run them yourselves. But basically what it does is that it will take a set of moves and simulate this display to then compute the score and log it on chain. Alright, so one important thing to notice is that strings are very expensive in terms of computational resources, right? So that's why we encoded the moves here in a binary format to make it cheaper and more efficient to run the game. So basically the idea is that you would have this cool UI interface in which the player would play the 2048 game, and all of his moves would be recorded, and then you would just take this set of moves and encode them into binary format and pass them to the virtualization unit alongside with your gaming logic bytecode after it was compiled by the Chains Atlas API. Alright. Right now in this example we just have the set of binary moves encoded here, but again you can just use the Chains Atlas EVMS load function here to load the argument from the memory, and you would just pass to it within your dApp logic. And that's it. So let's just play around with it, right? Let me just change the name of the file that we're using, 2048. And well, for this example we don't exactly have any arguments, so just set 0. We could set one argument. Actually, let's do that. I'll just set the one argument here. Let me just take this set of moves, and we just use Chains Atlas EVMS load 1. Okay, so you can see that it really works. And let's base it as an argument here. Cool. Right, and now let's try it again. And let's run our 2048 game. Just wait a little bit. Cool, so my score was 32, and this is the transaction hash. Whoops. Which we can verify again here in the transaction explorer and see that yeah, it was executed 19 seconds ago. It was a success. So guys, feel free to play with it, register, it's free, right? So you can go ahead, generate your API key for free. Stay tuned to our changes. Once you sign up, you'll also be put in our newsletter list, so we'll let you know once we have new updates. We promise we won't spam you with unnecessary mail just for important stuff. Also, take a look at the Discord channel. The link is in the description. There we can help you with the tutorials if you have any problems or any doubts, and you also find a community of developers in case you want to build cool stuff together using Chains Atlas technology. Okay, and stay tuned in the Discord channel also, because we will be hosting some hackathons using Chains Atlas technology soon, so stay tuned to receive this information as soon as it goes out. Okay, thanks for your attention, everybody. Bye bye.